Hello all the students. Today we are going to study lattice. So what is a lattice? Now if I consider a poset S comma R, obviously S here is an arbitrary set and R is a partial order defined on set S. So as per the definition, a partially ordered set S comma R is called a complete lattice or a lattice if every subset of set S has both a greatest lower bound and a least upper bound. The greatest lower bound is also known as meet and the least upper bound is also known as join. Now consider here that I am talking of every subset. That means every subset of the set S must have a greatest lower bound and a least upper bound, only then it will be called a lattice. So in that case, even if a single subset does not have a greatest lower bound or a least upper bound, then it will not be considered a lattice. Now let's look at this diagram. So is the given hash diagram a lattice or not? Let's see. We know that a hash diagram is called a lattice if it is both a meet semi-lattice and a join semi-lattice. That means if it has both a greatest lower bound and a lowest upper bound. Or in other words, we can also say for all x comma y that belong to set S, the greatest lower bound for all the ordered pair x, y must not be equal to null. Similarly, for all x comma y that belongs to set S, the lowest upper bound for all the x and y must not be equal to null. Now let us see some incomparable pairs. Obviously here we are talking about every pair. So when we talk of every pair, that means we must consider both the incomparable and comparable pairs. But in comparable pairs, it's very important for the greatest lower bound and the lowest upper bound to exist. Hence, we consider only the incomparable pairs. Now, if I look at the incomparable pair F and E, so the greatest lower bound for F and E is equals to B. Because if we trace downwards, we can see for E and F, the first meeting point of E and F is B here. Hence, the greatest lower bound of F and E is B. Similarly, if I look at the least upper bound of F and E, so the least upper bound, if we trace upwards, we see that G is the first meeting point of F and B. Hence, the least upper bound of F and E is G. Similarly, if I consider the incomparable pairs C and D, so the greatest lower bound for C and D is B and the lowest upper bound for C and D is G. Then if I look at the two incomparable pairs E and D, so the greatest lower bound for E and D is B. If I trace downwards like this, I see the first meeting point of E and D is B. Then the lowest upper bound of E and D is G. Again, if I trace upwards like this, E and D have the first meeting point at G. Hence, the lowest upper bound of E and D is equals to G. If I see the incomparable pairs C and D, so the greatest lower bound of C and D again here is B and the lowest upper bound of C and D again here is G. Then if I see the greatest lower bound of the incomparable pairs C and F, so the greatest lower bound of C and F again here is B and the lowest upper bound of C and F again here is G. So I can see that all the incomparable pairs have a greatest lower bound and a least upper bound, and it's quite obvious that the comparable pairs will have a greatest lower bound and a lowest upper bound. So that means I can say that the given hash diagram is a lattice. Now let's consider one more example. If I look at this particular hash diagram, now I have to find out whether this is a lattice or not. Now if I consider the incomparable pair F and G, then in that case the greatest lower bound of f and g, as I can see, is null. That is, they do not have any greatest lower bound. Similarly, the least upper bound of f and g is here h, but the greatest lower bound here is null, and as per the condition it should have both the greatest lower bound and the lower upper bound, and this implies for all the subsets. So even for a single subset this condition does not satisfy, then this Hasse diagram will not be considered a lattice. Hence I can say that the given Hasse diagram is not a meet lattice. Why a meet lattice? Because it does not have a greatest lower bound, and hence it is not a lattice. So this is all about lattice. I hope you understood. Thank you for watching.